Hey everybody, this is Larry. This is me going over day 2 of the weekly contest for 56 longest common prefix between adjacent strings after removal. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem. Yeah, so this one, I don't think there's anything tricky in algorithmic terms, right? There's no crazy complexity. I think the first and biggest thing to notice is that even though it is a Q2, look at you look at N and L, and they are too big for you to do a brute force and square, right? Type problem, right? The numbers are just too big. So, but it's still not insurmountable. It's just about figuring out, just about figuring out what the cases could be, right? And for me, honestly, I struggled a lot with this problem during the contest as a result. Some of it is because it is Q2 and I just didn't respect it at all, and I was just trying to rush for it to get to the heart or something like that, which worked okay previously. But the idea, actually, if you visualize it, is not so bad, right? So let's say you have a lot of buckets, right? And this relates to other problems that are with similar things. In this case, the scoring function is the longest common prefix, which you can get very quickly or relatively cheaply. But let's say this is the best pair, right, for the entire. Let me change the colors real quick. Let's say this is the best. All right, let me change the color real quick for Rio this time. Why are you not listening to me? Colors. All right, I don't know why, but okay. Let's say this is your best pair, right? Well, what does this mean? That means that if you remove any other well, there are a couple of things, right? That means that, okay, let's say now we will try to remove this. What does that mean? That means that, well, now you have some extra cases, right? Because now this red thing is no longer good enough for you, of course, but that means that there are only two new things that are new, right? So there's one that is the best of all the other pairs on the left and the right, right? So we calculate that first, of course. But then the other thing that is new is that now that we X this out, then we have this one and this one, or this one and this one to consider. So you have a lot of edge cases like that, right? So this is one thing that you can do, right? So now you have what I call the best thing, and then the rest is just going to be best, let's just say second best, right? So best two. In a similar way, I'm going to change the color real quick. If we remove this one, it's the same idea, right? Remove this one, then now we already have the best two, which involves indexes not including these two. So then now we just have to look at, well, now this one is free to create a new best possible pair. So you checked here, and also maybe check this one, right? Basically the two adjacent ones here, and that's the general idea, right? Okay, so those are the two things. Otherwise, for every other cell here and here, then now this best thing has to be in consideration, right? Because we don't need to do an n squared thing, because, for example, what this one and this one, whatever score it is, and we already calculated, well, removing this does not change. Let me change the color though. Hang on, let me change the color real quick. Use too many colors. Let's say this one and this one, we don't care about it if we remove this one, right? Like, they don't change, and whatever this is always going to be strictly worse than this is anyway. So we don't even care about that, right? Because this is always going to be Gucci. The only thing that we worry about this is that now we have to combine this one and this one, which is a new pair that we have not previously considered. And that's all there is. That's basically it, honestly. For me, the code is a little bit yucky, the way that I implement it, and maybe we'll spend a little bit of time to optimize it. But we'll go over it quickly first. The main reason being that, the main reason is just that I got 4 wrong answers on this one, and so a lot of things are hacked together after the first attempt, and you welcome to watch the live portion into seeing how all these silly mistakes. But honestly, I just kind of missed some cases. First of all, I have this function that gets the LCP, right? it is what it looks like. It just looks at one character at a time, it adds to the prefix, otherwise we return early. Otherwise, then now for each adjacent pairs, we calculate the best and then also the second best, right? So yeah, keeping track of what the index is for the best. And then after that, this is also this is just to keep track of. So okay, so let me document in this a little bit, right? So now find the best and second best, keeping track of indexes. And then here now, okay, and maybe this could have been inside the if statement anyway, but I don't know, I took it outside, which is that, okay, if we are removing, and yeah, maybe we need to write this a little bit better. We are removing the best or the second best, yeah, the best indexes actually. We have to consider the new pairs again, and that's basically what this is, right? We remove the best if there is a best index, if we remove best index, then now, oh no, I think I got them mixed up in different order, but this is if we're removing best index plus 1, so the right side of the pair, then we just do some if statements. I mean, I'm not gonna go over it, it's just very self-explanatory. And then if we're removing best index, and again, that's why I said that maybe these could be inside the next for loop instead, because I think looking back, this is a little bit out of place, but at least in terms of for, right? Because then now here, we just look at for each one, we go, okay, if this is at the left side of the best index, like the best side of the best pair, we just get the best I. And of course, this best I is actually literally just, maybe we'll write that now, right? So we put this here, and then we, okay, actually I put this in the wrong place anyway. Very easy to make mistakes. Yeah, and then now we can just put these two here, and obviously it doesn't change anything ideally because the other answer is correct, but it just makes it easier to kind of follow the flow a little bit better, right? Because now they're more contained within itself. And then now you don't need this anymore. It could be here, right? But yeah, this is saying, okay, what happens if we remove the left side of the best index, the right side of the best index, and now this is more in line, which is maybe better for understanding the flow. Given to the code, maybe you could say it's still pretty ugly. Otherwise, then now, if we can, if there's a new pair to be created after removing I, then this is what we do. Otherwise, we just append best, and that's it. And then we return answer. That's basically it. Like I said, I think if you're deliberate about it, it's not so bad. I end up taking 20 minutes because I keep on, like I want to say mostly done. Ideal, like I have the idea at about 10 minutes, but I just spent 4 long answers of debugging and etc. on like silliness. And you can watch that during the live portion. Honestly, I just missed cases because I was trying to rush it, and I was like, oh, this looks pretty good, pretty okay. But apparently my confidence meter is too confident, right? Maybe I should have just spent more time because I end up taking a lot more time anyway and still ate 20 minutes of penalty. Of course, this isn't a real contest, but still, you should treat yourself as such. Anyway, this is the LCP. This is to find the best and the second best. And that's it. Yeah, and the second best really only comes in handy when you're dealing with the original pair. But yeah, but that's it. Let me know what you think. Thanks for watching. And of course, this is gonna be linear time, linear space, linear in the number of characters, because if you look at this because for each word we only do about 3 comparisons. And so, yeah, with like 3 other words at most, or maybe 4, I don't know. I didn't count it out. But either way, it's a constant number of them, so it's going to be just linear in the length of characters. And that's it. that's what I have with this one. Let me know what you think. Thanks for watching. And yeah, you can watch me solve it live, mess around with this problem live next. I wasn't that confident about it, but all right. Well, now we get to move on. LCP adjacent strings have to remove. Okay, so you have this thing. Removed element index I from the words index. Computer or prefix. I mean, in theory, you have to just do 2 of them, right? It's still very annoying though. So okay, so word lengths are pretty big. So can you even look at every word and look at the adjacent ones? Very awkward problem. Okay. Can we do it once at least? Is my point. Should be, right? Oh, this thing. I missed this part. That makes it possible. Okay. Yeah. Okay. I was like, that doesn't make sense actually. So I had to double check my head for a second. But okay. So okay. So best is equal to 0. Best 2 is equal to 0. Best index maybe is equal to -1, say. Yeah. Count is equal to go I plus 1, or maybe just whatever. If count is greater than best, then best is equal to count. Best index is equal to I. Else, I'm trying to think whether it should be okay. That should be true. I think one thing that I do miss is that actually no. I thought I could do second best, which is maybe true, but no, that means that you have to do removal. Okay, yeah, so maybe that's actually okay. Yeah, and then now we remove I, so that means that we'll remove I or I plus 1. So we do for count is equal to go I, we remove I plus 1. And count is equal to best 2. No, we still need to keep track of best 2, but yeah, okay. That we just have to see whether okay, yeah, okay, fine. Actually, I was wrong here. Else if count is greater than best 2 is equal to count. Okay, and then now we have to try removing here. Yeah, then best 2 is equal to count. If I minus 1 0 I minus 1 I plus 1, oops, and then now enter for I in range of n if I is not equal to best index and I is not equal to best index plus 1, enter dot append best, else ascend dot append, or if it's not, yeah, then if it is, then we just return best 2. I think this is roughly right, but really used to make a silly mistake here. And of course we have to implement the go function, which I definitely forgot. I was ready to submit. I want to, right? if this is just annoying to write, that's why. Else just return P. Alright, this is way wrong, but that's fine. That's good. It's good that it's wrong now versus later. But why is this wrong? The longest is going to be these two. So what is the best index? Why is that wrong? Okay, so the best index is 1. Best 2 is 3. That's why. Why is best 2 3? One of these things? And then one of these things. It's so weird to have this as a smaller window. Why is this wrong? One I and I plus 1. I think I see it. Because I'm a little bit imprecise here, to be honest. Because if it's I, no, this isn't best 2. This is like best. I mean, there is a best 2, but there's a difference about best I. Let's just call it best I. Is you go to best 2, say, and then now we can save count. You go to best I, and then maybe best I plus 1. And then now if I is equal index. No, this is skipping the I. This is skipping I plus 1. I mixed them up. Okay, fine. Okay. If it's equal to best index, then enter that append best skipping I. Else if I is equal to best index plus 1, enter that append best skipping 1. And then else we would just return best. Okay, still wrong, because we skip best I is 1, which is true. So we skip this. Best 2 is 0. Is that true? That's probably true actually. But how do you get a 3 skipping 1? Because that's best I. Best I is going to be 0. This is going to be I minus. Oh no! Why did I have I here? That's why. It should be best index, not I. That's pretty bad, actually. I mean, the idea is right, but obviously, actual implementation is pretty bad. All right, that was just dumb. Okay, this looks better, but now it gives me a lot of not confidence. But let's YOLO submit. Probably gonna get wrong answer, but we can use this to instead of try to figure out for 5 minutes. All right, 0, 1, 2, 3, 4, 5. Okay, so here it thinks the answer is 2 because it removes these 2, right? I see. I actually thought about this case, but for some reason I forgot about it just because there's so many weird cases. Okay, so then now we. This is, which one is I? Oh. Huh. No, this is the case. I didn't consider that. I thought it would be one of these cases, but I was wrong. I think there is a case in which if you skip I, I'm just being sloppy. This is not wrong. This is not right at all. Or maybe it is. It's fine. But I think it's this or. Also, I wanted to do this. I forgot. Okay, I mean, this is actually, yeah, that's actually my bad. So it's not, I implemented, or maybe I rushed it, honestly, even though it should have been a very obvious thing. I was thinking, because I was thinking about it. That's the annoying thing, is that I thought about it and then I just kind of forgot about it. Okay, actually I don't use fmin anywhere, so I lied. But okay, so else, we have the best, or if we skip this one, so maybe just f max of this, and then go of I minus 1, I plus 1. I think that's fine, as long as, yeah, so if I minus 1 is going to be 0, and I plus 1 is less than n, then we do this, else, oops, did I skip a parens? Else answer.append best, give us a 1. Now that fixes it. Did it fix the other two? Or not fix, but make it incorrect. I've been very bad at checking for those. Let's give it submit. Ugh. Output 3. Where do you even get 3 from? Do I have a typo somewhere? Huh. Alright, I mean, clearly I have some weird... Oh, it probably went I minus 1 somewhere. And then it wrapped around or something, maybe? I don't know. That's very weird, actually. Okay, so best is 0. So then... What? How did I get 3? What? What? I thought I checked everything, everywhere. How do you get 3? I mean, okay. I is your best indexes, so it's not your best index, or this should be this. So is it here? Well, yeah, it has to be, because best is 0 otherwise. So go I minus 1 is greater than 0, and I plus 1 is less than n. So for I is equal to 1, this should be just here, right? I'm so confused. So we go here after, so no, here is this thing. So that means that this one went here. Whoops. Alright, well, let's do it here instead. And that is, oh no. Then why? Oh! Wait. Oh, because best index is -1. I am so dumb. Best index is -1 just from here. Alright, let's do -5. Oh. Wait, where? I am so dumb. It's and then now you have these things. Or this one anyway. I'm so dumb. Okay, let's just call it none. Yeah, I was just trying to be... Alright, and then none of these other things should run. Okay, none type and this one. Alright, oops. Okay, I think these are all right. I just didn't handle... that's a very, I don't know, sentinel values are bad. Okay, YOLO submit. More confident this time, but still no! Larry, what is going on? Alright, let's see, 0, 1, 2, 3, 4, 5, 6. So we remove this one, we get 0, right? 0 is here, but 1 is the best outside, which makes sense because it's these two. But then why am I not choosing best 2? I don't know. Okay, so let's see, 0, 1, 2, 2, 3, 4, 5. So it's this one. We move this one. Then there's one outside, right? Is that not best 2? Or just best? No, because best is 4. So 0, 1, 2, 3, 4. So this is the best is with this. Oh. Because tiebreaker. Because this is the pair. So we move this one though. This one now actually ties with that one. This is now a 1, even though it doesn't have max anymore. And this is 0. So then now, so we're moving this one is not just I see. Okay, how do I adjust for it though? So okay, so I'm really bad at this one clearly. So okay, so you have this. So okay, so let's say we move I, then now this one can actually look at this one as well. I mean, not in this case, but that means that if I, then I actually also matches with okay, so no, let's do this one first actually. Okay, so we move I, then now it's going to be I plus 1 and I plus 2, right? Because now it's I and I plus 1, so now that one is free to match with other things like this one. Okay, I mean, I guess that makes sense. I guess best index plus 1 by definition should exist, but now we also want plus 2 is less than n. Right, this one's tough, honestly. Yeah, for me anyway. So then now here, if we move this one, then now I can handle I minus 1, right? I and I minus 1, right? Yeah, and there is some symmetry here, so hopefully that pays off. But if I wasn't so much YOLO already, I would have maybe invested a little bit more. But did I not do this one? No, I guess not. I'm doing like 1 test cases at a time. If I had a secret test case, I would have been screwed. But okay, I thought I fixed this though. 0, 1, 2, 3, 4, 5. Okay, so this is the best answer. The DC for 2. So we remove this one. The answer is 1 from here, right? But don't we have that? So sad this farm. Okay, 4240. Why? Because we have a best 2 here, right? No. Oh, actually, I did this part. I'm dumb about because this one I should have had. Oops, the other way. Because this is a very obvious cascading thing. But then I remember why I forgot is because I deleted this because I thought this would handle it. But then I forgot to add it back in when I was like, oh wait, no, I still need this. Dumb. Okay, again, YOLO. Please. Okay, that was 4 wrong answers. Not very good. You know. Alright, well, can't all be bangers. How did it take 3 minutes on the first one? Oh, right. Oh, that's the try problem. I guess that makes sense. Okay, Q3. But now I think I could cheat a little bit in looking at the leaderboard. But the leaderboard doesn't mean anything anymore because it's just all cheaters anyway. Because usually it gives me a hint of like, to see how hard this problem is when I'm behind, so I could kind of, you know, judge it based on the leaderboard. But the leaderboard doesn't mean anything anymore because everyone cheats. So, all right. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye bye.